Hey, it's Mr. Marlowe again. We're going to do another short video this time, I hope. And today we're going to talk about combining like terms. How if you've got an expression that's got more than one x or more than one y in it, you can combine those so that you only have one variable term. So we're going to start with this little example, and we all know that 4 plus 3 is 7, so that this would actually be equal to 7c. But what I want to do here, though, is illustrate the distributive property process again. And remember, if you don't want to or can't do what's inside the parenthesis, you can use the distributive property that says that if I multiply what's outside the parenthesis by each part, I would get the same result if I added later. So c times 4 is 4c. c times 3 is 3c. So I get 4c plus 3c. And you're like, well, okay, that's great. But what I want to do is I want to go backwards from that now. We know that c times 4 plus 3 is equal to this. So what I'm going to do here is start where we wound up and talk about how we can get back to here and then what we can do with it. So this would be a situation. I have an expression and it's 4c plus 3c. All right. And what I can do is I can say, hey, the distributive property tells me that both of these are being multiplied by the same thing, the variable c. What I can do is it's called factoring, because this is a factor and this is a factor, this is a factor and there's another one. C is the common factor. I can factor that c out and say, I'm going to multiply in a minute. Instead of multiplying the same number twice and then adding the results, I can factor that common factor, that variable c out, and what's left inside is 4 plus 3. And now we already know that that's equal to 7c. Okay? So we're starting here. Our thought process takes us there, and then here we are. Now, another thing to remind everybody, the 4 and the 3 are called coefficients. And what did we wind up doing? We simply added the coefficients on the variables. So when the variables are the same, okay, we can combine them by just combining the coefficients. All right, it works whether it's, positive or negative or whatever. So let's take a look at a couple of examples. Like I said, this one should be pretty short. All right, and let's do this. 6c, well, not 6, but let's do 6x minus, I don't know, 4x. All right. Well, once again, the long way says that x is being multiplied by both 6 and 4. So I can use the distributive property and factor that common factor out, x. And what's left? Inside would then be 6 minus 4. The distributive property tells me that, yes, I can multiply x times 6 and get 6x. All right? And again, so what am I going to do here? Well, hey, I can do that. 6 minus 4 is 2 times x. So instead of 6x minus 4x, I've got 2x. Now, obviously, once you get the hang of this, this is an optional part right here, because once again, what are we really doing? We're combining the coefficients on the variables. But like I said, I just wanted you to see, where does that come from? It's one thing for me to come up here and say, okay, if the variables are the same, just combine the coefficients and tack the variable in there. But this way I'm showing you why it's happening. All right? And again, what if I was doing negative 3y minus, say, 10y? Okay? Well, again, same situation. The variable's in there twice. okay? It's the common factor. The distributive property says that I can factor that out. I can hold that common multiplier out, and what's left? Negative 3 minus 10. And again, I have had students tell me, Mr. Marlowe, I can't find the Y button on my calculator. Well, now we don't need it. The Y is waiting patiently out here, and negative 3 minus 10 is negative 13. Y. And again, so that is how it's called combining like terms. When the variables are the same, we can combine them. Technically, we're using the distributive property and we're factoring out the common factor, the variable. But what we really wind up doing is simply looking at the coefficients and combining them, either with subtraction or addition. But like I said, that's the next key step in simplifying expressions, is realizing how can I take these variable terms and combine them into a single term. I will do one more as a last example of the fact that it doesn't have to be just 2. If we look at something like 6x plus 3x plus, say, x, okay? This time I have 3 terms with x in the expression, okay? Well, let's do the same thing. Since they're all being multiplied by x, the distributive property says I can factor that x out, just hold it for later. And now I go back and say, okay, what's left? 6 plus 3 plus, had an x, and now there's an x over here. Well, if I tried to leave it as a 0, when I went back and did my distributive property, I wouldn't get an x here. Okay? Well, what do I multiply by x to get x? 1. It's that ghost 1, the hidden 1, whatever. Okay? Anytime you have a naked variable like that, okay, it's got that hidden 1, the fairy godmother 1, if you will. There's a 1 floating there until you need her. And there she is, the fairy godmother. So what do I do when I pull that x out? I'm left with my 1. And then I just combine the coefficients. Remember, any variable that does not have a coefficient, a number being multiplied by it, has a 1. Okay? So again, I'm going to remove that so that you realize that it started off without 1. There's the 1, because again, you're doing the distributive property. X times 6, 6x. X times 3, 3x. X times, I need a 1, 1x. And then I combine them. So there you go. Okay, again, that was just a very, hopefully, useful but brief explanation of how we can combine more than one variable term so that we just have one. Hope it was useful. We'll see you next time.